Question 10. Stylish computer desk made of laminate wood, non-scratch top. Length is exactly 2,000 millimeters. Luke wants this new desk for his bedroom. The desk is to fit on the length of straight wall between his wardrobe and his bookcase. So it's going to go in this little section here. Luke has measured the wall, which is 600 to the nearest 10. When you're doing greatest least values, you always half the units. So in this case, half of 10 is 5. So that means, and then you add and take it on to the 600. So his least wall, the shortest wall, is going to be 595. And the longest wall, the biggest wall, is going to be 605. When we're looking at the bookcase to the nearest centimetre, nearest one, half of 1 is 0.5. So his smallest bookcase is going to be 147, take away 0.5, which is 146.5. And his greatest, his longest, is going to be 147 plus 0.5, which is 147.5. And then the wardrobe, again, half of 1 is 0.5, so the wardrobe is going to be between 249.5, because 250 take away 0.5, and the greatest is going to be 250.5. So let's have a look at this question. Write down the greatest possible length of the wall. We did that earlier. Half of 10 is 5, 600 plus 5 is 605. The least possible length of the wardrobe, half of 1 is 0.5, 250 take away 0.5 is 249. Across the wrong one, so it's 249.5. Part C. Can Luke be certain that this desk will fit in the space available? We must show the calculations. To find out whether he's going to be certain, okay, we need to look at what possible problems could we have. We could have the wall being the shortest length, and the shortest length of wall would be, okay, as we worked out earlier, would be 595 centimeters. But then we could have, okay, we've got to see what fits into there. So we're looking at the wardrobe. All right, what would happen if we had a big wardrobe? A big wardrobe, the biggest possible wardrobe to take up that gap from the earlier part of the question would be 250.5 centimeters. And we could also have the big bookcase to take up as much space as possible. So the big bookcase, which would be taken off, okay, the biggest possible bookcase we had was 147.5. So what I'm going to do now is work out where these two add up to find what the gap is left. 5 add 5 is 0, is 10, sorry, 0 down, carry the 1. 0 add 7 add 1 is 8, 5 add 4 is 9, 2 add 1 is 3. So that comes to 398 centimeters. So that means my smallest possible gap, because I took the smallest wall and tried to fit the biggest things within there, would be 595 take away this, which is 398. So 595 take away 398 becomes 5 take away 8 you can't do, so you borrow. 15 take away 8 is 7. 8 take away 9 we can't do, so we borrow. 18 take away 9 is 9. 4 take away 3 is 1. So my smallest possible gap would be 197 centimeters. So our desk now, if we go back to the first question, the desk is exactly 2,000 millimeters. Doesn't say to the nearest. So if I change that to centimeters, there's 10 millimeters in the centimeter. So that would become 200 centimeters. So the desk would not fit in the smallest possible gap, because 200 centimeters would not fit into a gap of 197 centimeters.